What is the value of that expression? 24 plus 12 is 36. That looks to me like 16 minus 4, which is 12. So that looks like it will be 3 as a final answer. If 3k is equal to 10, what is the value of 6 over 5k minus 2? So that 6k, this guy right here, I'll split it into 2 times 3k. And then we've got 5 in the denominator and then minus 2. Well, this 3k is 10, so sub that in there. And then therefore 2 times 10 is 20. 20 divided by 5 is 4. So that is just 4 minus 2, and that's 2. Segment AB is reflected in the y-axis to obtain ED. Segment BC is reflected in the y-axis to obtain DC. Determine the sum of the slopes of DC and ED. All right, I think I'll have to extend this line a little bit. I'm going down, and let's just see. AB is extended, has to be extended in order for it to reflect. And then if it reflects, and this is the y-axis, right? It's going to go up exactly like this, like that. It should pass through 2 and that point, which is the exact mirror image of A. And they're calling that ED. So, I'm not entirely sure where is E and where is D. They don't label E and D, do they? So I'll just call this point D, this point, and I'll call this point E, I guess. Okay, and then what's this next one? BC is reflected also. So BC, that's reflected, so I guess it's going to be like this. And that's DC, and DC is already labeled. Well, I labeled D. Okay, now what are they saying? The sum of the slopes of DC and ED. So, okay, let's figure them out individually. DC is rise over run. So the rise, it's a downward. This is, yeah, it's downward. So the rise is actually minus 4. Yeah, and then the run is 2. So that slope is minus 2. And then ED, that slope, that one's going up. So the rise is plus 6, and the run is 2. So that's 3. So the sum is minus 2 plus 3, and that is 1. A spinner was created by drawing 5 radii from the center of a circle. The first 4 radii divide the circle into 4 equal wedges. The 5th radius divides one of the wedges into 2 parts, one having twice the area of the other. The 5 wedges are labeled as pictured, with the wedge labeled by 2 having twice the area of the wedge labeled by 1. Determine the probability of spinning an odd number. Okay, I think we'll have to work with angles. So this is obviously 90 degrees, this is obviously 90 degrees, and that's 90 degrees. If 2 is twice the area of 1, then that means this would be 60 degrees, and this little guy in here would be 30 degrees. And I think that's pretty much all there is to it. So the probability of spinning an odd number, so odd number is either 1, 3, or 5. So the probability would be, the total is 360 degrees all the way around, but the probability of a 1 is a 30 degrees. To getting the 3 is 90 degrees, and to get the 5 is also 90 degrees. So that looks to me like 210 over 360, and that's 21 over 36. And I think we can go a little bit further, 7 over 12. I think that's in lowest terms. Maggie graphs the 6 possible lines of the form y is equal to mx plus b, where m is either 1 or negative 2, and b is either 0, 1, or 2. For example, one of the lines is y is equal to x plus 2. The lines are all graphed on the same axes. There are exactly n distinct points, each of which lies on 2 or more of these lines. What is the value of n? Okay, so using m is either 1 or negative 2, and b is either 0, 1, 2, we can come up with the following lines. Y is equal to x, y is equal to x plus 1, y is equal to x plus 2. And then using the other slope, it would be minus 2x plus 1, and minus 2x plus 2. Minus. Okay, so then I'll just really briefly, draw a little sketch. Doesn't have to be super accurate, but let's see here. Let me use different colors here. So for these guys, I'll use red. So here's the y is equal to x, and then x plus 1 would be a little bit higher, where that's 1, and then x plus 2 would be a little bit higher, where that's 2. And then let's use green. So we're graphing these guys now in green. So, oh boy, let me see here. Something like this. This is that y is equal to minus 2x. And this is, oh, didn't do a good job there. And then there we go. Something like that, right? So now we want to figure out each of which, the distinct point, the points that lie on two or more. So I guess, are there any intersection points? Well, I see 1 here, 2, 3, 4, 5, 6, 7, 8, 9. I see 9 of them. And I hope you also see 9 also. So therefore, n is 9. And I think that's all they're getting at there. How many perfect squares are greater than 1 and are divisors of 60 to the power of 5? Okay, so 60, first of all, let's break that up into prime factors. I believe it's 2 times 2 times 3 times 5, right? So that's 2 to the power of 2, 3 to the power of 1, 5 to the power of 1. But we have to take it to the 5th power. So 60 to the power of 5 would be all these guys all to the power of 5. And that I believe is 2 to the power of 10, 3 to the power of 5, and 5 to the power of 5. Okay, so how many of these guys are going to be, the divisors, I mean, are going to be perfect squares? Well, any divisor will be of the form 2 to the power of a, 3 to the power of b, 5 to the power of c. And it's a perfect square if a, b, and c are even. That's the only way. So we have to choose values of a, b, and c that are even. Okay, well, my candidates for a, since a can be anything from 0 to 10, right? So the even numbers are 0, 2, 4, 6, and 6, 8, and 10. 1, 2, 3, 4, 5, 6. So there's 6 possibilities there. I'll just put that 6 in a circle. For b, my number can be anything from 0 to 5. So the even choices are 0, 2, and 4. So we have 3 choices there. And then for c, same kind of story. It can be anything from 0 to 5, but we want the even ones. So 0, 2, and 4. So that's 3 choices. So if you add them, if you multiply them, you got 6 choices for A, 3 choices for B, and 3 choices for C. So 6 times 9 is 54. But here's the thing, there's a tricky question. They will only want the ones greater than 1. So we don't want 1. So we've got to subtract that. So it's 54 minus 1, which is 53. Because if A, B, and C all equal 0, then this expression would be 2 to the 0, 3 to the 0, 5 to the 0, which is 1. And this is not valid. Not valid. Why? I mean, it's a perfect square, but they don't want it because they want perfect squares greater than 1. So therefore, we have to not count that one. And that's why the answer is 53 and not 54. "27 unit cubes are each colored completely black or completely red. The unit cubes are assembled into a larger cube. If 1/3 of the surface area of the larger cube is red, what is the smallest number of unit cubes that could have been colored red?" So let's draw a cube and let's see what kind of situation we can get here. And what are they saying? 27. Okay, that definitely helps. So it helps to know the number is what I meant. So let's just see if I can put in 27. Yeah, I think this is not drawn to scale, of course, but that's 27. You can count them. There'll be 9 in each sort of slab, and then there's 3 slabs, so that'd be 27. Okay. Now they're saying, well, first let's figure out the surface area. The surface area, that looks like a 3 by 3, right? So the surface area would be 3 by 3, and then we've got to multiply that by 6 sides. So 3 by 3, that's 9. 9 times 6 is 54. So that's the total surface area of the cube. Now they're saying that 1/3 of the surface area is colored red. So 1/3 of 54, which I believe is 18. They want 18 whatever units. They want that to be colored red. And they want the smallest. Okay, so this is the word here. Smallest number of cubes that could be colored red. Because I'm sure there's several ways of doing this. Okay, the smallest way would to have each cube sort of maximize the surface area. So, for example, if I chose a corner, let me just draw that in. So this is a corner cube, right? And let's say that were to be colored red. That corner cube gives 3 units. Corner cube gives, each side is a 1 by 1 because they're unit cubes. So it gives a 1 by 1 times 3. So it gives 3 units in terms of the surface area. So if we just had 6 of those, 6 corner cubes, it would be 6 times 3, and that would be the 18. And that would be sufficient to match that 18. Now, the key to the word here is smallest, because you can do it in other ways. You can have, let's say, this guy, but that would only contribute 2. So you'd have to have, let's say, 9 of those in order to get 18. But they want the smallest. So I think the answer to this question would be 6, and then you can explain that it would be 6 corner cubes. That would be sufficient to come up with 1/3 of the surface area being red. Gina's running app tracked her average rate in minutes per kilometer. After starting the app, Gina stood still for 15 seconds and then ran at a constant rate of 7 minutes per kilometer for the rest of the run. How many kilometers did Gina run between when her app showed her average as 7 minutes and 30 seconds per kilometer and when it showed 7 minutes and 5 seconds per kilometer? Okay, speed is usually given as distance over time, where they're giving it as time over distance, which is very confusing. See, they're saying 7 minutes per 1 kilometer. And usually it's given as like 1 kilometer over 7 minutes. Yeah, or you know what I mean, kilometers per minute, kilometers per hour. So that's the confusing part, but fortunately we can just flip it. So let's draw a little diagram. So let's say this is the start, and then she gets to a certain point, and we'll call that distance D1, and then she gets to the last point, and then we'll call the total distance D2. So this is what we're interested in, this part. They're saying how many kilometers did Gina run between when her app showed her average rate is 7:30. So this is, let's say, when it shows 7.5 minutes per kilometer. Again, very confusing since we usually give speed as, kilometers per minute or kilometers an hour per hour. And then at this point, this is when her average is 7 minutes and 5 seconds. So whatever that works out to, 7 and 1 over 12, is it? Yeah. 7 and 1 over 12. Because I've got to convert this minutes per kilometer. And they are saying, what is this distance here, I guess. So that's just D2 minus D1. Okay, I think that shouldn't be too much of a problem. Let's do this. Okay, so speed is equal to, for the first guy, D1 over time. So let's see here, the average and then time would be d1 over s, right? So d1 over speed. Now the speed, I've got to convert it, into kilometers per minute, but I've got to use this number, so 7.5. So I'm going to flip it. So it'd be 1 kilometer over 7.5 minutes, like that. So that's going to be 7.5 d1. I'm going to just get rid of the units there. Okay. And then that basically was the average. So the average is calculated, that 7.5 d1 is calculated as follows. First, you add the 15 seconds that she stood there, which is a quarter of a minute. And then you add the actual time she was running, which would be, let's see here. Let's do that on the side. The time would be d1 over s. This is just the time that she's running, so that'd be d1 over 1 over 7. 1 kilometer in 7 minutes, so that'd be 7d1. So that's 7d1 right there. And when you solve for d1, you'll get d1 equal to 0.5. All right, so then we do the exact same thing this time for the next segment, this guy here. So similarly, for 7 minutes and 5 seconds, that is 85 over 12, if you convert it to fractions, this time for d2. And again, it'd be 1/4 the 15 seconds that she stood there. And then the entire time that she runs, this whole d2 would be 7d2. Because time is d2 over speed. And then the speed, if you use it as kilometers per minute, would be 1 kilometer for 7 minutes, per 7 minutes. And that would be 7d2. So that's how I get that 7d2. And when you solve for this, d2 is equal to 3. So we wanted d2 minus d1, so that is 3 minus 0.5, and that is 2.5. So that's the answer. Square ABCD is inscribed. ACDE is inscribed in a circle centered at O with radius root 2. Point B is on the circumference of the circle so that BE and BD have the same length. Line segment AC intersects BE and BD at F and G respectively. Determine the ordered pair AB of integers so that the area of BFG equals A plus B root 2. Okay, so let's draw in a few lines here. And that hopefully will help us. And hopefully we can solve this. I'm going to have to label a couple of these points. This point here I'll call H, and this point here, that sort of between F and G, I'll call J. Sort of stick that J in there. And I think that should be sufficient. So let's keep going here. All right, so a few observations first of all. Since it's a square, when I draw that X, we get these angles like AOC, that is 90 degrees. And another observation is Pythagoras will allow us to figure out the side of the square, since we know the radius, because we have this Pythagorean relationship of OE plus OD is equal to ED. And OE is the radius, right? And the radius they're saying is root 2. So root 2 squared is ED squared. And then when you solve for ED, you will actually get just 2. Okay, and then we also know, one other observation here, that EOH, that angle in there, is going to be 45 degrees, since that red line BH is sort of cuts it in half, cuts the 90 in half. And then therefore EOB would be 180 minus 45, so it would be 135. I don't know if that helps us in any way. But one thing is for sure, because AE is parallel to BH, then that means that this angle, let's just say it's theta, and this angle would be the same. So that actually helps out a lot, because that makes me think that EFA, that triangle, is similar to triangle which one? Let's see here. Triangle EHB. Yeah. EFA would be similar to triangle EHB. Yeah. Okay, so that helps. Let me just move this up a little bit. So that helps how we can now make a comparison. AF over AE is the same as EH over BH. So EH, well, the side length was 2, so EH is going to be half of that, right? So that's just going to be 1. BH, all the way from top to bottom, well, BO, that's just the radius, so that's root 2. And then OH, well, that's just half of the side length, so that'd be 1. Yeah, so I'm pretty sure that's right. And then therefore AF would be AE times that 1 over root 2 plus 1, and AE, that's 2. That's the side length. So this becomes 2 over root 2 plus 1. Yeah. And then we have to get rid of that radical. And then when we do that, we will get 2 root 2 minus 2. So that's AF. Okay, that's pretty good progress. Now we'll concentrate on trying to get FG. FG is that little guy up there. The whole side, AC, if you subtract from that AF and then subtract from that GC, you'll get FG. Now, AF and GC are the same because of the symmetry of the diagram. So AC was 2, right? And then AF we just figured out. And then GC is the same. So there we go. That would mean 6 minus 4 root 2 for FG. Okay. It's pretty good progress, I think. And then next we have to start figuring out, we're going to have to figure out BJ, that tiny little height. Because we have FG. Yeah, because if we want the area of BFG, that small triangle, we're going to need the height and the base. We got the base, FG, but we're going to need the height, BJ. So to get the height, let me think about this here. There's got to be another similar triangle situation. Let me see what kind of similar triangle. Triangle, I think just BFG, the triangle that we're focusing on, if we just compare that to the big guy, BED. Yeah, that would do it. And those triangles are definitely similar since they have the exact same angles. So that means BJ over BH is the same as FG over ED. So that means that BJ is equal to BH times FG over ED. And then now we can plug this in. BH, I believe, BH, well, that's just top to bottom, so that we'd already done that here, right there. So that's root 2 plus 1. Okay. And then FG is here, so that's 6 minus 4 root 2. And then ED, well, ED is just the side length, so that's just 2. So therefore, when you crunch out these numbers, you get root 2 minus 1. Okay, so we are all set to figure out the area of BFJ. So the area of triangle BFG, I should say, BFG, is 1/2 base times height. The base is this guy, so that's FG, so 6 minus 4 root 2. The height is BJ, which we just figured out is that, so root 2 minus 1. So yeah, and then when you crunch out these numbers, it's minus 7 plus 5 root 2. And they're saying that is equal to, right here, A plus B root 2. So therefore, that means that A is minus 7 and the B is 5. So minus 7.5 is the answer to this question. Find all quadruples ABCD of positive integers which satisfy those equations. Well, as always, probably going to use some fancy algebra. Hopefully not too fancy. So here we go. So I'll call this equation 1, call this equation 2, and call this equation 3. So from the first one, we're going to say factor out an a and we get b plus 2. And then at this point, we have to use a little bit of fancy algebra. It's not extremely difficult, but we want to somehow factor this. So if I were to put a minus 2 here, what I do on one side, I'd have to do on the other side, I have to put a minus 2 there. Now, why did I do that? Because that allows me to factor. So this would become b plus 2. This is 56. And this now allows me to factor a b plus 2. And then it would become a minus 1. So that was the goal, and that's why I did that. So this is my new equation 1. And in a very similar way, you can do the same kind of thing with equations 2 and 3 to factor them. And equation 2 factors to b plus 2c plus 4 is equal to 308. And equation 3 factors to c plus 4 times d minus 6 is equal to 77. So we now have 3 equations that are sort of modified in a way that allows us to kind of fiddle around with this a little bit better, I think. Okay, so that is step 1, and now let's concentrate on trying to figure out the actual values of a, b, and c. So let me start with equation 3, this guy right here. So that states that c plus 4 times d minus 6 is equal to 77. Now they're all integers and they're all positive integers. So possibilities for c plus 4, well, 77 is 7 times 11, right? 7 and 11 being prime numbers. So that means c plus 4 could be either 7, it could be 11, it could be 1, or it could be 77. If c plus 4 is 7, that means c is 3, and therefore d would be the 11, and then d minus 6 would be the 11, and therefore d would be 17. In a very similar way, if c plus 4 is 11, that means c is 7, and that means d minus 6 would be the 7, and therefore d would be 13. If it's 1, c ends up being minus 3, and that's no good because they have to be positive, so we can't use that one. And then if c plus 4 is 77, then that means c is 73, and therefore d minus 6 would be 1, and therefore d would be hold on. If c plus 4 is 77, then d minus 6 would be 1, and then therefore d would be equal to 7. Okay, so that's so far we've got some pretty decent candidates. Now we have to figure out a and b. So, but we can only use c equal to 3, 7, and 73 because this one is invalid because it's negative. Okay, so we will now use equation 2 to solve for b. So b plus 2 is equal to 308 divided by c plus 4. So when we plug in c equals 3 to this equation, we get b equal 42. When we plug in c equals 7, we get b equal to 26. And when we plug in c equals 73, we get b equal to 2. Okay, so far, all of these are integers, so that's pretty decent. So now let's concentrate on solving for a, and we'll use equation 1 to solve for a. So the equation 1 states that a minus 1 is equal to 56 over b plus 2. So when b is 42, when we plug that in, we get a equal to 1.2. So that's no good because it's got to be an integer. When b is equal to 26, we get a equal to 3. And when b is equal to 2, we get a equal to 15. So it looks like the only ones that worked that were integers. So let's see here. When a is 3, b is 26. When b was 26, c was 7. And when c was 7, d was 13. So that is one possibility. Another possibility looks to me like when a was 15, that made b 2 right there. When b was 2, c is 73. And when c was 73, d was 7. So these are the two quadruples that satisfy those original system of equations.